Now let's discuss about this question that was asked in morning shift. So which of the following is water soluble protein? To answer this question, let us first understand the classification of proteins on the basis of their molecular shape or molecular structure. Basically, proteins are classified into two categories. Number one is fibrous protein and number two is globular proteins. So on the basis of their molecular shape and structure, they are classified as fibrous proteins and globular proteins. Now first understand some points about fibrous proteins. Basically, these proteins are linear and thread-like molecules. Now, in them, the polypeptide chains basically run parallel. These polypeptide chains, they are held together by strong hydrogen bonds. So there is hydrogen bonding present in them and disulfide bonds. So these chains are held together by hydrogen bonds and disulfide bonds. As a result, the molecular forces of attraction in them, they are very strong. That is basically responsible for their insolubility in water. Hence, fibrous proteins are basically insoluble in water. Because of the presence of high intramolecular forces of attraction, strong intramolecular forces of attraction, these are insoluble in water. Now let's understand the examples of them. So there is again a point before doing example. Please remember that these are stable to moderate changes in temperature and pH. Fibrous proteins are basically stable to any moderate change in temperature or pH. So examples of fibrous proteins are basically keratin, that is present in our skin, hair, nails and wool. Number two example is collagen. That is present in tendons. Number three example is fibroin. That is present in silk. Next example is myosin. That is present in muscles. So these are the important points regarding fibrous proteins. They are linear. There is strong hydrogen bonding. That there is force of attraction stronger. That is, they are insoluble in water. Now let's talk about globular proteins. Basically, globular proteins are folded. They are spheroidal in shape. There are basically non-polar parts and polar parts present in them. Non-polar parts are sometimes also named as lipophilic and they are generally pushed inwards. While the other part, polar part, water soluble part, hydrophilic part, they are pushed outwards. Now as a result, the water molecules, they can basically interact strongly with these polar groups and hence globular proteins are water soluble. So this is very important point of globular proteins, that they are water soluble. So water molecules, they can interact strongly with the polar groups, polar parts. They are very sensitive to any small changes in temperature and pH as compared to the fibrous proteins. These are basically very sensitive to small changes in temperature and pH, where in the case of fibrous proteins we have studied that these proteins are basically stable at moderate changes in temperature and pressure, while globular proteins, they are very sensitive to small changes in temperature and pH. Now let's see the examples of globular proteins. Globular proteins includes all the enzymes, hormones such as insulin, thyroglobin, that is from the thyroid gland, antibodies, these are basically responsible for the allergies and defense against any foreign organisms. Haemoglobin, that basically transports the oxygen from blood to the muscles. Fibrinogen, which is basically converted into insoluble protein fibrin, and thus it causes clotting of the blood. And the last one is albumin, that is in eggs. So albumin is an example of globular protein, and globular proteins are basically water soluble proteins. So this was basically asked in the question that which of the following is water soluble protein. Fibrous proteins are insoluble, so D is our answer. Water soluble protein is albumin.